Again, it says use algebra to solve this equation. Again, our equation has a cos and a sine. So we have to think, is there a way that we could write this with only one trig function? And here we can use the big idea, sine squared plus cos squared equals 1. So sine squared is equal to 1 minus cos squared. I can change that in my equation. And instead of writing sine squared, I can write 1 minus cos squared instead. Now my function has only cos. Probably can solve it. Distribute that 2. Combine my like terms. 3 minus 2 plus 1. See if we can factor this. Again, if you're unsure if you can factor it, you can always use the quadratic formula. This is a really easy one to factor because if it's going to work, it has to be 2 cos x and cos x. And to get 1, it has to be 1 and 1. So now you just have to check, is there a way to get minus 3 in the middle? If they're both negative, my outside's negative 2, my inside's negative 1, that makes negative 3. And so here we get cos x is equal to 1. And here we get cos x is equal to 1/2. Are those on your pie plate? Yes. When is cos equal to 1/2? Pi over 3 family, quadrant 1 and quadrant 4. When is cos x equal to 1? 0 and 2 pi. Once again, we'll go back, reread the question, make sure our domain said between 0 and 2 pi. Oh. It says between 0 and 3 pi over 2. Does that make sense that they're only looking from 0 to 3 pi over 2 is only looking in quadrants 1, 2, and 3? Did we have any answers outside of that? Yes. This one was in quadrant 4. Got to take that one out. 2 pi is too far. Have to take that one out. So it's just 0 and pi over 3. Now I feel like I want to double check. Was 0 included or not? Yes. 0 was included. 3 pi over 2 wasn't, but that wasn't in our solution. So the only solutions to this one are 0 and pi over 3. All right, question for practice on this one is number 10.